Alright, so this is the 12th problem in the grind 75. This is balanced binary search tree, or just a balanced binary tree. We're given 15 minutes, and so we're going to start the countdown now. So let's see. Okay. Given a binary tree, determine if it is height balanced. For this problem, a height balanced binary tree is defined as a binary tree in which the left and right subtrees of every node differ in height by no more than 1. Okay. The left and right subtrees. So say of every node. Okay. Oh, let's see. Is this false? Of every node. Yeah, so the root, its left subtree, and this is its right subtree. And those subtrees must not differ in height by more than 1, which they don't, so this passes. The root, its right subtree, and its left subtree. The left subtree has, is of height 3, 1, 2, 3, and this subtree is of height 1, just stemming from the root. And so this obviously doesn't pass. So it can be at most 1, it can also be 0. So how would we determine this? If it's empty, I guess we would also return 0. Let's look at the class that we have. So we have a way to create new nodes as well, although we probably will not need to do that. Okay, so I mean, what just came to my mind, which might not be the most efficient solution, is recurse down left, recurse down right, count each time you recurse. If difference is greater than 1 or less than -1, I guess. Greater than 1 or less than -1. Then we would return false. Return false, else return true. However, okay. I believe we do have to touch every node. I mean, not necessarily. I mean, if we get to this point right here, we should know that this already doesn't work. We don't have to recurse through the entire tree. This solution appears to be O of n, but let's just actually get it down. And if it passes, then we can optimize from there. So let's see. I'm going to make a separate function actually that's going to be called height, and it's going to take in a tree node root and an integer, we'll call it count for now. And just to account for the base case, if root.val is equal to null, then we're going to want to return true. Otherwise, we're going to call height, and we're going to pass in root dot left and root dot right. And this would actually be an integer. However, I'm just trying to think about where we want to keep the logic. While root dot left, we're going to pass in comma 1. Here would be int height, pass in root dot right, comma 1. I guess we should start off with 0, technically. If root dot val is equal to null, then we just want to return count. And let's see. We're also going to want to do comparison. So if height called on root dot left minus, so we can get int difference, call that is equal to height on root dot left minus height on root dot right. Okay, and then if difference is greater than 1 or difference is less than -1, then we're going to technically want to return false, but that really should be done up here. We return true. If difference is greater than 1 or if difference is less. Okay. Else. I did not clearly write out the logic and I sort of got lost in what I wanted to do. Okay. Count each time we recurse. If the difference is too big, then return false, else return true. Okay, so that is our base case. If difference, else guess we would return is balanced on we would want to go down both sides. I feel like I know what needs to be done. I'm just not thinking of the right order in which to do it. So we want to check if left subtree is the same height as the right subtree. So we have the root. We're also not even incrementing the count anywhere. I'm jumping back and forth from like task to task. I just want clarity of thought where I can start from the beginning and work through the end rather than trying to put the pieces together as I go. Okay, so left, we want to get the height, right, we want to get the height. We were getting the height by going to the left and going to the right, and then getting the difference and returning that difference. And count plus 1, count plus 1 for difference. If the root is equal to return count, so I'm sort of getting confused as to where I'm keeping track of where I'm actually doing the left and right operations. I mean, I have this up here, but I don't believe that's the right spot to do it on. Is balanced root dot right and is balanced root dot left. So maybe we start off by passing in just root to height. So we're going to say int difference is equal to height. We're going to pass in root, and we're going to set the count equal to 0. Okay, we have a minute left. I'm just going to stop the timer for now and think about if this makes sense. So we have a check for null here, so maybe we can actually take this out. That seems unnecessary. We're going to get the difference by doing that. If difference is greater than 1, or so that would be okay in the case that we have an empty tree. Else we're going to return is balanced root right and is balanced root dot left. So let's say we go here and we go here. We're going to call int difference. It's going to start out with 0. Then so let's look at maybe 20 first. Pass in the difference is going to be the height of left and right. Am I doing the recursive step at the right place, though? I feel like the height is not being kept track of, though, because I'm resetting it. But then it doesn't necessarily need to be. It's just we need to see if the heights on particular levels are mismatched. So, let's see. Left, 9, right, 20. We're going to check if they are the same height. We're going to pass in the root. That's going to give us a difference. And the difference is going to be the height of the left and the right. So say we have this one. Root dot left minus root dot right. So this our initial right recursive call will yield 1. This will keep going until it yields something great. Then it's going to yield difference. Difference is going to make us return false. So I believe we don't even need this. We should be able to return true. And let's check the test cases. Missing semicolon. Okay, that's not a good look. Let's see. Read.val is equal to null. It's val, right? Yes, it is val. So why can't I do is null though? Should be double equals is an integer, int val. Still a tree node object. I don't see what the error is here. I will stop the video here. I will push through the logic on my own, but we're going to straighten everything out in the solution.